Good morning, students. This is our vehicle dynamics class, and today we will discuss the topic of stability of vehicle on a curved bank track. So, to understand this topic, you have to understand this diagram first. So, this is your road surface, and it is a banked road. That means it is having an angle of theta with the level surface. So, it is a banked road, and at the same time, it is a curved road as well. So, this is your four-wheeler vehicle which is approaching towards you, and while approaching towards you, it is also taking a turn towards the left side, and towards the direction in which I am pointing the arrow. So, due to the turn taken by the vehicle, it is acted upon by centrifugal force CF, which passes through the center of gravity of the vehicle, and this CF will be converted into two components, CF cos theta and CF sin theta. One is horizontal component, that is CF cos theta, and one is vertical component, that is CF sin theta. Now, from the center of gravity of the vehicle, this perpendicular force is the W, that is weight of the vehicle. And the weight of the vehicle is also converted into two components, that is W cos theta and W sin theta. This T represents the wheel track, and X and Y are the distances of inner wheel from the center of gravity and outer wheel from the center of gravity of the vehicle, respectively. H represents the height of the center of gravity from the road surface. So, this Fi is the reaction force on the inner wheels, Fo is the reaction force on the outer wheels, Fwi is the friction force on the inner wheels, and Fwo is the friction force on the outer wheels. So this completes the description of this figure. So before going further, you should understand all the forces acting on the vehicle. So let's see what are the forces. So if vehicle traveling at a certain velocity in a curved path on a banked road will have three forces acting upon it. One is the centrifugal force, as I have told you. When the vehicle will take turn toward the left side, it is acted upon by centrifugal force, which is going to act towards the right side. This is CF. The value of the vehicle's weight, that is W. So this weight of the vehicle is the second force which is acting downwards, and the friction forces FWO and FWI. So these two are the friction forces on the inner wheels. I represents inner wheels and O represents outer wheels. So now, for example, consider a case when the centrifugal force and weight of the vehicle acting from the center of gravity, and the resultant of these two forces is perpendicular to the road surface. Now see this angle. This is a 90-degree angle. Means if the resultant of centrifugal force and weight of the vehicle, which is R, and this R is perpendicular to the road surface, then your vehicle will not slide either towards the left side or towards the right side. Means your vehicle will be completely stable. The condition is that your resultant of the centrifugal force and weight of the vehicle should be perpendicular to the road surface. Now see how. If the resultant force R of the forces CF centrifugal force and W weight of the vehicle acts normal or at right angle to the road surface, then no weight or loading has been transferred from the inner wheels. Means that if this resultant of CF and W is perpendicular or normal to the road surface, then the weight transfer from inner wheel to outer wheel will be zero, and your vehicle will not slide. And there is no tendency for the vehicle to slide at this velocity. And road radii means there is a particular velocity of the vehicle at which the vehicle will not slide. Means now consider yourself, if the vehicle speed is decreased, means the vehicle is very slow, this centrifugal force will also be reduced, and due to reduced centrifugal force, the vehicle may slide toward the left. So there is a particular velocity of the vehicle at which the vehicle will not slide. And what is that velocity? Is the velocity when the resultant of the vehicle's centrifugal force and weight of the vehicle is perpendicular to the road surface. So when the resultant force is acting normal means perpendicular to the road surface, the vehicle should behave as if it was traveling along the level road surface. Means when the vehicle will not slide, neither left nor right side, the vehicle is not sliding. It is similar to the concept of vehicle moving on a level road. That is, the effect of banking has been neglected. So good design and engineering play important part towards the safety on the road. So this can be achieved by proper designing of the automobiles and proper techniques that you have to apply before finding the parameters of the vehicles. Uh, with the help of these design considerations, you can design the vehicle so that it does not slide on the banked surface. So now from this diagram, we have to calculate the angle theta. That is, we see this triangle. Uh, this vertical side is W, this horizontal side is CF. This CF, W, CF, and this hypotenuse is R. So we calculate the value of theta. We apply the formula for tan theta, and tan theta is opposite side upon hypotenuse, opposite side upon adjacent side. So opposite side is CF, and adjacent side is MG. So this is tan theta is opposite side CF and adjacent side W, that is mg. So tan theta will be CF upon mg, and put the value of CF, which is mv square upon r. The CF is mv square upon r. M and m will be cancelled, so v square upon gr will be your tan theta. From this relation, we can calculate the velocity. V is equal to tan theta into gr under root meter per second. Means if your vehicle will move with this velocity, your vehicle will not slide on a banked road, and it will be completely stable. The second case will be vehicle sliding on a banking. Now, this today we have discussed the vehicle when it is not going to slide on a banked road. In the upcoming video, we will consider the case when the vehicle is going to slide on the banked road. Okay, so hope you guys understand. Thank you.